In this lesson, we're going to be graphing from slope-intercept form. And as we go, we're going to be graphing both equations and inequalities, as you'll see. Now, our first example that you see here, it is an equation because it has the equal sign in it. And this equation is in slope-intercept form. Now, slope-intercept form of a line is a very old and familiar one, so hopefully this is a review for you. The big idea of slope-intercept form is that the number that's being multiplied by x is your slope, which you hopefully remember is a way of describing the rise over the run, how much you go up and how much you go over as you draw your line in. Remember, it's slope-intercept form. The other part is the y-intercept. That's always the number that's being added or subtracted on the end. And so in this case, our slope is 2 and our y-intercept is -5. When I go to graph this then, I'm going to start by plotting my y-intercept down here at -5. And then from there, my slope is 2. Now, you might be thinking, yeah, if it's rise over run, but what is 2? Because 2 is not a fraction. But we can write it as a fraction because any number can be written as a fraction by writing it over 1. So 2 is really just 2 over 1. So notice the rise is 2 and the run is 1, which means that from that starting point that I already plotted, I'm going to go up 2 and I'm going to go over 1. Now, when we talk about going over, we're going over to the right. So I can just continue going up 2 over 1, and up 2 and over 1, all the way along, and I can use that same pattern to just plot all of the different points that are on this line. And once I do that, then I want to grab a straight edge and draw the line that goes through all of those points. When all is said and done, this is what you should be looking at then as your final graph. Now this time, notice that it's no longer an equation up here. Instead, we have an inequality. That just means that instead of an equal sign, we have an inequality symbol. And there's many inequality symbols that it could be. In this case, it's a greater than or equal to, but there is also less than or equal to, just greater than, and just later than, less than rather, that it could be. So all of those are possibilities about the different types of inequalities that you might see. And yes, if you ever have trouble remembering what they're each called, you might want to make note of that because certainly we'll continue talking about them in those terms of using the correct words for each one. All right, now, in this case, we're being asked to graph it. In order to graph it, it works the same way as the equation did, where I'm going to be starting at my y-intercept of -5, and then with a slope of 2, I'm going to go up 2 over 1, up 2 over 1, in order to be able to fill in that line. And yes, we do the same thing going the other direction, follow the same pattern of just then it's down 2, left 1, down 2, left 1, and then we can draw the line in through those points. And so far, this looks exactly like it did before. However, the difference is that since it's greater than, what it's telling us then is that any point on one side of this line is actually a solution. It's really just a matter of figuring out which side that is. And there's actually a nice, easy way to be able to recognize it. Because this line that we have over here is really what the 2x minus 5 is. We want to shade here all of the points where the y-coordinate is more than that. Notice then, that would mean that we'd be looking above our graph. And so then any point above my graph here has a y value that is more than the line. And hence, my final graph will look like that. And if it were a less than or a less than or equal to, we would have still put the line in the same place. The only difference is we would have been shading below instead. Now let's look at one more variation of this same basic structure here. Just this time, instead of a greater than or equal to, this one is just greater than. And so what difference does that make? Well, it actually only changes one thing. It means that the points that are right on my line, where the y was equal to it, those should not actually be included as part of our solutions. The shaded area should be, but not the actual points right on the line. And so the way we show that then is we use a dotted line. And so anytime you have that equal to in there, you draw the solid line like you normally would. But if you do not have the equal in there, so it's just a greater than or it's just a less than, draw your line as dotted. And by doing so, you're showing that the points that are right on the line are not included in the answer, but this one's greater than, so we still have to shade. I shade above then since it's greater. And you'll notice then that that shaded area, it shows us that all of those points are included, but if I actually got right on the line because it's dotted, those would not be solutions. From here, we're just going to take a look at a few more examples real quick. All right, so next up, sometimes people worry a little bit when there's a fraction in there, but in some ways it makes it a little bit easier. This again is in slope-intercept form, where the 2/3 is my slope and my y-intercept is 1. So I'm going to start by plotting that y-intercept. So on the y-axis, I go up to +1, and then my slope is 2/3. And that means the rise over the run is 2/3. So it's telling me from that starting point, I want to rise 2 and then go over 3 in order to be able to get to my next point. And I'm just going to keep following that same pattern of up to over to the right 3. And then when I go the other direction, that means I'm going down and to the left. I can tell which direction I need to be going because I'm just following the pattern that I saw with the other points. Now I need to draw my line in, and since this actually is equal and it's not an inequality, it is just a line. And so then this would be your graph for this particular problem. Now I do want us to see what would happen if it were an inequality. So what if we change it up just a little bit? In this case, it is y is now less than 2/3 x plus 1. Well, the basic starting point's the same, where I'm still going to start up 1, and then I'm going to be going up 2 and over 3 on both sides to be able to plot my points, and then I need to draw my line in. Question, so you can check yourself. When I draw my line in here, will it be solid or dotted? Notice that since this is not a less than or equal to, that means it's dotted. The equal to part makes it solid. So without that, it's dotted. Now from here, I need to shade. In this case, it is less than, and if y is less than that line, then I need to go below the line when I shade it. All right, let's take a look at one more set of examples. In this case, we have y equals -3x plus 4. So if I'm just going to graph the equation here, notice my slope is going to be -3. When your slope is negative, it's kind of like when we think about our rise over run, that the -3 is what's over 1. So notice that our rise is negative and the run is still positive. So I still start at my y-intercept, but then instead of going up and right, my rise is negative, so it's going to be down, but the run is still positive, so I still go to the right. So I go down and to the right. And once I got that first point down, I'm just following the same pattern of right 1, down 3, or so on. Down 3, right 1, either way you want to do it. And then we can go ahead and draw our line through those. Now that's the equation version. Now let's go ahead and look at an inequality version of the same thing. In this case, it's y is less than or equal to the -3x plus 4. My points will all go in the same place. In this case, when I draw my line in, should it be solid or should it be dotted? The or equal to part, that tells me it's solid. Then I need to shade. Notice that that is a less than or equal to symbol. Less than is below. And so I shade all of the values that are below my line there, and then I'm done.